believes Zimbabweans are capable of spearheading game-changing, first-of-a-kind innovations that challenge the world's traditional ways of doing things.
A brief trip into the future.
The vehicle, it uses what we call the microsonic energy device. The microsonic energy device, it is the device that I personally invented in 2009.
A car that never needs gas, never plugs in, and just keeps running. It sounds impossible, right? But it's real. And it's not coming from Tesla or Toyota. It's emerging from Africa, where a quiet inventor from Zimbabwe may have cracked the code to a truly self-charging vehicle. No wires, no fuel, just motion. And the most surprising part? It's not just a prototype. Mass production is now on the table, and the global auto industry is beginning to panic. This could be the start of Africa's auto revolution. While the United States is dealing with chip shortages and obsessing over Tesla's next move, a massive transformation has been taking place across the Atlantic. In just a decade, Africa has gone from being a dumping ground for used vehicles to designing, building, and exporting its own. These aren't flashy concept cars built for tech expos. They're tough, practical machines built to withstand the real world. Designed for survival, not just to coast through Silicon Valley traffic, Africa's auto industry is rewriting the rules. Morocco leads the charge. In 2024 alone, its auto factories in Tangier and Kenitra rolled out over 610,000 vehicles, 90% of which were exported directly to Europe. That makes Morocco Africa's top car producer and the second-largest vehicle supplier to the European Union after China. With a total factory capacity of more than 1 million vehicles per year, Morocco now produces about 1,700 cars daily, outpacing many long-established European plants. Next is South Africa, which has long set the gold standard for engineering on the continent. With decades of manufacturing experience, it's home to major global players like BMW, Ford, and Toyota. Over 100,000 people work in South Africa's auto plants, with an additional 300,000 employed across the supply chain. Around 60% of vehicles built in the country are exported. But what makes them stand out is their rugged durability. Bakkies and SUVs designed to handle tough terrain, complete with dust-sealed electronics and reinforced suspensions. Then comes the rising underdog, Nigeria. In the town of Nui, Innocent vehicle manufacturing has grown rapidly. In 2020, they could build 10,000 vehicles per year. By late 2024, that number had increased to 15,000. They also debuted Nigeria's first locally built electric pickup truck. These aren't cheap knockoffs of Western models. They're stronger, built with thicker body panels and reinforced welds to endure the cratered roads of Nigeria. Ghana is making similar moves. Kantanka Automobile produces up to 7,000 pickups and SUVs annually, most of which remain within the country. They're even experimenting with solar-powered drivetrains to cut fuel costs for taxi fleets that spend hours on the road each day. Kenya's automotive journey has been full of ups and downs. Mobius Motors, based in Nairobi, had to temporarily shut down its factory in 2024 due to funding issues. But with new investment, they're back on track. Their latest model, the Mobius 3, is set for full production in July 2025. This rugged SUV, built 60% from locally sourced parts, features a turbocharged 1.6L engine and a ladder frame tough enough for farm tracks and rural terrain. Africa isn't just building cars, it's building supply chains. In the past, raw materials were mostly imported. Now, local production is booming. Kenya's Devki Group operates a massive coastal steel mill producing 500,000 tons annually, cutting frame building costs by nearly 20%. In Egypt, a €1 billion factory in the Suez Canal Economic Zone is on track to produce 7 million tires per year, many destined for Morocco and Nigeria. Upholstery leather tanned in Nigeria's Kano state now ends up in dashboards in Ghana and South Africa. This shift to local sourcing keeps money and jobs within Africa and reduces dependency on foreign suppliers. What really sets these African-made vehicles apart is their resilience. Ground clearance under 200 millimeters isn't even considered. Suspension parts are overbuilt. Radiators have stone guards. Electronics are tightly sealed to prevent dust damage. Unlike Tesla's sleek but sensitive designs, African automakers build for mud, sandstorms, and floodwaters. Steel conduits protect wiring. Traditional buttons replace delicate touchscreens, because these vehicles must work, no matter what. For instance, one Innocent G6 pickup might haul cassava in the morning, drop kids off at school in the afternoon, and navigate a flooded road at night, all without needing a laptop to reset a system. While electric vehicles are gaining traction globally, Africa faces a unique challenge: electricity. More than 600 million Africans lack reliable power. Even in electrified regions, voltage drops and blackouts are common. Africa also has the world's lowest charger-to-person ratio, less than one charger per 10,000 people. So, long-range EVs like Teslas are impractical outside major cities. That's why self-charging in Africa looks different. We're talking hybrids with regenerative braking, solar roof panels, or alternator systems that charge batteries while the engine idles. These solutions may not look glamorous, but they keep lights and tools powered even when the grid fails. And this no-nonsense approach is working. In northern Ghana, farming cooperatives report cutting maintenance costs by 30% since switching from used imports to locally built Kantanka pickups. In Kenya, safari companies prefer the Mobius 3 for its dust-sealed cabin that prevents costly breakdowns. In Nigeria, telecom technicians use Innosense EV pickups to power tools and laptops directly from the truck's 20 kilowatt-hour battery. Even global automakers are taking notice. Volkswagen's plant in Kigali now sources dashboard components from plastics factories in Nairobi. What started as an underdog movement has evolved into a full-blown revolution. Africa's auto industry isn't just rising, it's driving the future on its own terms. Stellantis, the multinational automaker that owns brands like Jeep, Peugeot, and Citroën, is already exploring Morocco's interior for a new SUV production line targeting the West African market. But here's the bottom line: Africa isn't chasing luxury car trends or trying to compete with Tesla. Instead, the continent is solving real transportation problems for real people. It laid the groundwork with rugged, locally made vehicles, and China wasted no time jumping into the race. While Western automakers hesitated, unsure whether self-charging vehicles were viable or just a gimmick, Chinese investors acted swiftly. They started building factories, forming partnerships, and making deals across the continent. The logic was simple. Even if the technology wasn't perfect, the opportunity was massive. If electric vehicles could perform reliably on Africa's rough roads and unstable power grids, then they could succeed anywhere. In Nairobi, the Chinese connection is already delivering results. A Kenyan startup, BasiGo, has put 17 electric buses on the road, each built in collaboration with Chinese EV giant BYD. With support from a Shenzhen-based parts company, Kenyan engineers are now designing cheaper power modules to make EV production more affordable for the local market. Over in Uganda, China's CHTC is partnering with the state-backed Kira Motors to refine solar-powered hybrid buses. Their goal is clear: reduce dependence on diesel and the power grid by making public transport more self-sufficient. These partnerships aren't about colonial control, they're about mutual development. China's engagement in East Africa doesn't stop there. In May, Ethiopia banned new petrol and diesel cars, and China's GAC Group quickly responded by unveiling 2 plug-in hybrids tailored to the Ethiopian market. Chinese technicians are already on the ground, helping Ethiopian teams ramp up for local production. With no outdated gas plants to replace, Ethiopia is leaping straight into the EV era. West Africa is also part of the revolution. Nigeria, Africa's largest economy, signed an exclusive deal with Chinese automaker GAC through Lagos-based Coscarus Motors. GAC now sells compact EVs in Nigeria and may even begin local assembly if demand continues to grow. One of their models features rooftop solar panels and a backup generator, reducing both costs and reliance on charging stations, a far more practical solution than a Tesla in traffic-choked cities with unreliable power. South Africa offers another strategic advantage for Chinese automakers by providing access to more regulated markets. BYD, for example, plans to triple its dealership network in South Africa by the end of next year, launching 6 fully electric models and 2 hybrids. Their expansion coincides with growing competition in South Africa's automotive industry, which recently saw Golden Arrow Bus Services place a massive order for 120 BYD B12 electric buses, the largest EV bus deal in the country so far. So why is China moving so fast while others hold back? The answer lies in mass production. Chinese factories aren't waiting for the science to be perfect or the industry to reach a consensus. They're already rolling out thousands of electric minibuses and pickups equipped with solar panels, regenerative braking, and heavy-duty alternators. While not fully self-charging in the traditional sense, These vehicles are self-sufficient enough to operate effectively where electricity is inconsistent. For Tesla, this is a growing concern. China is Tesla's second-largest market, and if Chinese automakers like BYD, GAC, and GAC Tech can produce durable, affordable EVs for Africa and then expand to other developing regions, Tesla's dominance could be at risk. Chinese companies are also more willing to take bold risks, launching early and fixing problems later. Even if just one of their designs succeeds, it could sweep across Southeast Asia before Tesla finalizes its next big move. But this is more than just a competitive race. China is playing the long game by promoting its involvement as partnerships rather than power plays. This strategy resonates with African governments weary of Western restrictions and intellectual property demands. At a recent summit, South African President Cyril Ramaphosa described China's support as mutually beneficial and applauded BYD for helping address the country's chronic power blackouts. Meanwhile, BYD is pushing ahead to expand its South African network, solidifying its early lead. Although self-charging technology still has hurdles to overcome, China has already secured its position as a leader in the field. As these moves ripple through the auto industry, major Western carmakers are feeling the pressure. Auto giants once believed they had the electric vehicle race in the bag. They invested billions in batteries and charging networks, assuming that was the only path forward. But Africa's success with semi-self-sufficient vehicles, especially those that don't rely heavily on fixed charging stations, has flipped the narrative. Suddenly, every major automaker from Detroit to Wolfsburg is scrambling to adapt. Volkswagen, which once pledged an all-electric lineup within a decade, has delayed its scalable systems platform and is now reconsidering hybrid solutions. Toyota, ever cautious with EVs, has partnered with Chinese tech giants like Huawei and Xiaomi to test solar-powered drivetrains and lighter components for upcoming BZ models. Even Ford and General Motors are quietly funding innovations like enhanced regenerative braking and thin solar skins to reduce reliance on fixed chargers. Tesla, which invested heavily in its supercharger network, now finds that very infrastructure could limit its flexibility. Opening the network to non-Tesla EVs may help short-term, but it also reduces the company's competitive edge. In contrast, carmakers that didn't lock themselves into proprietary charging systems are now enjoying more adaptability. A recent Shell survey of 15,000 drivers revealed that over 40% of Europeans and one-third of Americans still hesitate to buy EVs due to charging concerns. If self-charging technology becomes reliable and mainstream, these skeptical consumers could flood the market, and automakers without charging infrastructure baggage will be best positioned to meet demand. While Western companies debate the next move, Africa's EV factories are already moving into high gear. In South Africa alone, the auto industry employs over 110,000 people, and that number is growing rapidly with the expansion of new self-charging vehicle production lines. The country is experiencing a multi-billion rand investment boom in the automotive sector. In Nigeria and Kenya, the demand for skilled workers, welders, electricians, and software technicians is rising. In Cape Town, Golden Arrow's purchase of 120 electric buses from BYD has secured years of production and local job creation. Unlike the automated megaplants in Fremont or Shanghai, many African car factories still emphasize hands-on craftsmanship, giving communities both economic empowerment and a stake in the future of transportation. Teams rotate through different roles, learning how to install solar panels, wire systems, and calibrate drivetrains. Workers aren't just tightening bolts, they're learning the technology inside and out, and that matters. They take pride in what they build, track performance, and offer feedback to improve future models. Labor unions that once feared automation are now backing this wave of innovation. In Zimbabwe, the Automotive and Allied Workers Union recently secured a 10% wage increase and improved housing allowances, pushing for higher standards as production scales up. In Nigeria, union leaders have tied worker bonuses to local sourcing goals, encouraging automakers to use more locally sourced steel, rubber, and fabric. It's a smart move. Management benefits from reduced logistics costs, and workers gain stronger job security. Everyone wins. Africa is proving that advanced manufacturing doesn't have to mean replacing workers with machines. It can mean training workers to become problem solvers and innovators. Every new hire who learns to install a solar panel or troubleshoot an alternator becomes part of something bigger. As industry giants scramble to adapt, Tesla has been forced to respond, and quickly. Tesla has faced competition before, but nothing quite like this. When word spread that Zimbabwean inventor Maxwell Chikumbutso had developed a self-charging electric vehicle, it sent shockwaves through Silicon Valley. A 44-year-old resident of Harare, Chikumbutso posted videos of his free energy car online, which quickly went viral and racked up millions of views in days. Though scientists and engineers around the world questioned the physics behind the claim, the public was captivated. The idea of a car that charges itself while driving seemed like science fiction, but it was gaining traction fast, and that alone made Tesla nervous. This wasn't just another electric vehicle announcement. Tesla's entire business model is built around charging infrastructure, with over $10 billion invested in superchargers, home charging units, and proprietary battery tech. If the public begins to believe cars no longer need to plug in, Tesla's greatest asset becomes a liability. A self-charging EV, even if only partially possible, threatens the very foundation of Tesla's dominance. Elon Musk didn't respond with panic, at least not publicly. He has long been skeptical of ambient wireless charging, especially at the scale needed to power a moving vehicle, and he's often pointed out that energy cannot be created out of thin air. He's right. Physics still applies. Yet, when Chikumbutso's story began trending, Tesla remained publicly silent. Behind the scenes, however, things moved fast. Musk reportedly ordered his top engineers to analyze the footage and explore whether any existing technologies could explain what they were seeing. Tesla's teams in battery systems, solar energy, and energy recovery were tasked with digging deeper, even if the idea sounded far-fetched. Meanwhile, Tesla was already developing its next major project, the Redwood, a compact crossover SUV slated for production by mid-2025 at Gigafactory, Texas. Leaked documents revealed that this model would target a price point below $30,000, half the cost of the current entry-level Model 3. Suddenly, there was added pressure to include features that could tie into the self-charging narrative. Engineers began racing to integrate solar skins, stronger regenerative braking systems, and a new 48-volt electrical platform designed to reduce energy waste. These updates wouldn't eliminate the need to charge, but they would help keep Tesla relevant in a world increasingly obsessed with energy independence on wheels. But Tesla's troubles were already brewing. Even before the self-charging buzz, their grip on global markets was weakening. In Europe, Tesla's share of new EV registrations fell below 1% this spring, marking 4 straight months of decline. And in April, Tesla's global quarterly sales dropped by 13%, the worst performance in nearly 3 years. So, when the Chikumbutso video went viral, it didn't just stir curiosity, it spooked investors. Within days, Tesla's stock lost billions in value. Analysts weren't only questioning the science of self-charging. They were asking if Tesla could maintain its lead at all if public enthusiasm for this concept continued to grow. Tesla didn't waste time exploring its options. The fastest move: accelerate the release of the Redwood and price it aggressively. If consumers can't yet have a self-charging car, maybe they'll settle for one that's affordable and extremely efficient. Behind closed doors, Tesla executives reportedly began discreetly contacting African labs to determine if Chikumbutso's design was real, scalable, or at least partially valid. These conversations were kept quiet, likely to avoid the appearance that Tesla was chasing a technology it had publicly dismissed. Internally, Tesla launched a new initiative called Project Infinite. The name sounds dramatic, but the goal is simple: find every possible method of recovering energy from a moving vehicle. Teams are now working on innovations such as harnessing energy from suspension movement, tire pressure variations, and even vibrations in the vehicle's panels. Most of these ideas are extensions of current energy recovery systems, but the hope is to eventually supply up to 15% of a car's daily energy needs without ever plugging in. Tesla plans to debut its first working prototypes by 2027. While these systems won't replace the supercharger network, they may allow Tesla to rebrand itself as a pioneer in self-sustaining mobility, rather than a company clinging to outdated infrastructure. Still, one major issue remains. No independent laboratory has verified the science behind Chikumbutso's self-charging vehicle. Physics maintains that energy must come from somewhere. Cars can't move without external input. But public perception often doesn't wait for peer-reviewed validation. If enough consumers start believing that plug-free driving is possible, even in theory, it shifts the entire EV conversation. Tesla's best chance now is speed. Deliver a low-cost, high-efficiency model, and maintain the brand's reputation for bold, disruptive ideas, not bulky charging cables. The irony: Tesla made electric cars cool, But now it's being challenged by the idea of a car that might never need to charge at all. Africa, once overlooked in the EV race, has shaken the system to its core. And the next few months will reveal whether Tesla can adapt or be left behind by a new kind of revolution. While Tesla may be planning bold moves, another technological breakthrough is already reshaping how electric vehicles get charged: charging roads. Just a decade ago, the idea of a road that could charge your car while driving sounded like science fiction. Today, it's a reality in multiple countries, and it's working. The system is simple in concept, yet advanced in execution. Just a few centimeters beneath the asphalt lie flat copper coils connected to the power grid. These coils generate a magnetic field, which is picked up by a special receiver installed beneath the vehicle and converted into electricity. Importantly, the coils only activate when an equipped vehicle passes overhead, reducing energy loss and ensuring pedestrian safety. This innovation is called a dynamic electric road system, and Sweden is at the forefront of its development. On the island of Gotland, engineers have constructed a 1.6-kilometer stretch of Smart Road Gotland, where a 40-ton truck has driven at 80 kilometers per hour while drawing up to 100 kilowatts of power, even in icy winter conditions. The success of that project convinced Sweden to begin building the world's first permanent inductive motorway, a 21-kilometer section of the E20 highway that is being prepped for electrification and is expected to open to freight traffic before 2026. That's only the beginning. Sweden plans to construct 2,000 kilometers of these roads by the end of the decade. Meanwhile, Italy is moving just as quickly. Near the A35 highway in Brescia, engineers developed a 1-kilometer test loop known as the Arena del Futuro. This road is powered at 1 megawatt and has already wirelessly charged a Fiat 500 and an Iveco electric bus while traveling at highway speeds. The transfer efficiency has surpassed 85%, a very promising result. Stellantis, the parent company of Fiat, claims this proves long-haul trucks could operate with smaller battery packs, saving both weight and cost. If testing continues successfully, Italy is expected to implement the same wireless system on an active highway stretch after it endures its second winter. In the United States, Michigan became the first state to activate a dynamic charging road. In Detroit's Corktown district, a quarter-mile stretch of 14th Street was equipped with wireless coils late last year. This $2 million pilot project is a collaboration between the state of Michigan, the city of Detroit, Ford, DTE Energy, and Israeli tech firm Electrian. Early tests with a Ford E-Transit van show that the system can add about 20 kilometers of range per hour at typical city speeds, more than enough to keep delivery vehicles topped up between stops. Officials have confirmed plans to expand the pilot to a full mile after more performance data is collected during Detroit's harsh winter. The biggest current hurdle is cost. A review of European infrastructure projects found that installing just 1 kilometer of inductive charging road ranges between €6 million and €20 million, depending on traffic volume and whether the road requires a full rebuild. Despite the high cost, governments continue to invest. The reason is simple. Heavy-duty trucks, which contribute to about a quarter of road transport emissions, benefit the most. If these trucks can cut their battery size in half, they'll be able to carry more cargo and save tens of thousands of euros per vehicle, driving both economic and environmental gains over time. This emerging technology is saving fleet operators money and making clean transportation more competitive, and it's catching on faster than anyone expected. In France, a new pilot project is being launched on the A10 highway just outside Paris. In Germany, engineers are weighing the benefits of wireless inductive charging lanes against the overhead cable systems already being tested on the A5 near Frankfurt. Meanwhile, China is pushing ahead rapidly with a 3-kilometer wireless charging corridor for buses under construction in Wuhan. In Israel, the company Electrian is developing a fully electric airport shuttle route that recharges while in operation. For everyday drivers, the impact of dynamic charging is greater than it might initially seem. It tackles the two biggest concerns that hold people back from buying electric vehicles: the high upfront cost and the fear of running out of charge. If the road handles part of your daily charging, the vehicle doesn't need to carry an oversized, expensive battery. This means cheaper cars, cleaner air, and quieter streets, especially in urban areas, without having to wait for every resident to install a home charging station. For rural routes and heavy transport, dynamic charging offers a viable alternative to building massive charging depots. It provides the infrastructure needed to make electric transport feasible without the overwhelming cost and logistical challenges of giant batteries. In regions like Africa, where rugged, self-sustaining vehicles are becoming the standard, transforming roads into energy sources simply makes practical sense. Critics argue that the system only works for vehicles equipped with specialized receivers. However, even that barrier is quickly being overcome. Electrian claims that mass production will reduce the cost of each receiver to under $2,000 within the next 2 years. While dynamic charging won't eliminate plug-in stations overnight and batteries aren't going away, this technology is no longer a futuristic experiment. It's actively solving real-world problems today. Thanks for watching. See you in our next video.